You see this image everywhere, right? On the news, in your classroom, definitely on your phone. It's the world, and it seems so simple. But what if I told you this picture, this thing we see all the time, is one of the most complex, story-filled documents ever created? Well, today we're going to prove it.
So, what we're looking at here is basically a satellite view of Earth. And yeah, it's beautiful, it's accurate, but it's also just the top layer. Think of it like the cover of a really, really big book. In this explainer, we're going to peel back that cover and start exploring the incredible chapters hidden just underneath.
And that really brings us to the big question, doesn't it? Is a map just a picture of some land and some water, or is it something more, like a tapestry, woven together from geology, from physics, and believe it or not, from human imagination? Let's find out by stripping it down, layer by layer.
Okay, first things first. Let's peel back all the colors, all the labels, and just look at the raw physical shape of our planet. This is the foundation, the canvas that absolutely everything else is built on.
Now, this isn't a map of forests or deserts. This is what's called a topographic map. And what it does is use color to show us elevation. The bright reds, those are the highest, most towering peaks. And those deep, dark blues, those are the deepest, darkest ocean trenches. You're literally seeing the Earth's raw texture.
So let's put some real numbers to that texture. The highest point on our entire planet is, of course, Mount Everest, soaring up to 8,850 meters. That is nearly 9 kilometers straight up into the sky. Incredible.
But you know, for every single peak, there's a valley, or in this case, a trench. The lowest point on Earth is the Challenger Deep, and it plunges to a mind-boggling negative 10,924 meters. Just think about that for a second. The deepest part of our ocean is over 2 kilometers deeper than Mount Everest is tall.
And this is where you really get a sense of the sheer range of our planet's physical form. Just look at North America alone, right? The difference between Denali, its highest point, and Death Valley, its lowest, is more than 6,000 meters. This is the absolutely dramatic physical stage for everything that follows. So, we've got our physical canvas. Now, let's add the next layer. And this one's completely invisible. It's an abstract grid of lines that we've drawn all over the globe. But here's the crazy part. These imaginary lines have a profound, very real physical effect on every single living thing.
It all starts right here, with the equator. This is our 0-degree baseline. Now, it's not a real line you can go trip over in the jungle, but its location is determined by the actual physics of how our planet spins. Absolutely everything in our climate system is measured in relation to this one line.
Okay, so starting from the equator, we draw other lines of latitude. And these aren't just random. They mark exactly how directly the sun's energy hits the Earth as it goes through its yearly orbit. And this is the crucial point. These imaginary lines create the world's very real climate bands. You've got the hot tropics, the moderate temperate zones, and the freezing cold polar regions.
And here they are, the tropics of Cancer and Capricorn. They basically draw a box around the area that gets the most direct, intense sunlight. Then you have the Arctic and Antarctic circles, which mark where the polar regions begin. You know, the places where the sun can stay up for days in the summer and disappear for days in the winter. These 5 lines essentially organize all life on Earth.
And if you ever wanted to actually see the impact of those invisible lines, well, this is it. On the left, you've got the Arctic, a world defined by that Arctic Circle. And on the right, the lush Congo rainforest, sitting right on the equator. It's the same planet, but 2 completely different worlds. And it's all because of where they sit on this invisible grid.
All right, we've looked at the physical world, and we've seen the natural climate systems that govern it. For our final layer, we're going to add something that is 100% a human invention, a system of organization that we have layered right on top of the physical globe, time itself.
Okay, let's do a little thought experiment. Just imagine, for a second, it's midday in London. The sun is at its highest point in the sky, it's lunchtime. Simple enough, right? But wait, what about everywhere else? While London is having lunch, people in Tokyo are probably getting ready for bed, and folks in Lima are just waking up and having their coffee. Now, before the 1800s, this wasn't a huge problem. But once you have trains and telegraphs, having thousands of different local times just becomes total chaos. We needed a system. And this was the brilliantly elegant solution. We divided the entire globe into 24 time zones. It was a simple but incredibly powerful way to standardize time across the whole planet. We literally wrapped the world in a grid of time.
The anchor for this whole system is something called Coordinated Universal Time, or UTC. You can think of it as the modern-day version of Greenwich Mean Time. Every single time zone on Earth is defined as being a certain number of hours ahead of or behind UTC. It's like the silent, coordinated heartbeat of our entire global civilization. So, there you have it. We've taken our simple world map and we've found 3 totally distinct layers hiding inside it. Let's put it all back together now and see what we've really learned.
We started with that fundamental physical layer, the rocks, the mountains, the oceans. Then, on top of that, we saw the natural layer, the one driven by pure physics, our climate zones. And finally, we added a purely human invention, our global system of time. See how each layer builds on the one before it?
And get this, those were just 3 layers. The really crucial point here is that a map can hold a nearly infinite number of stories. Take this one, for example. It doesn't show mountains or time zones. It shows the distribution of different language groups across Russia and Central Asia. It's a map of culture, of history, of human migration. Which really brings us to the most important takeaway of all. A map isn't just a picture. It's a text. It's a document that is jam-packed with information. Every single map tells a story. You just have to learn how to read it.
So, we've seen how maps can tell these incredible stories of geology, climate, and time. But what else is out there? I mean, think about it. You could map economic trade, the rise and fall of empires, internet connectivity, or even the spread of ideas. What other invisible human stories are out there, just waiting for us to put them on the map?